Counter in digital system is used in timer. I am taking the example of mod 8 counter. In the mod 8 counter, 2 raised to 3 is equal to 8. This is equal to 2 raised to n. Value of n is 3, which means that 3-bit counter. So each bit is associated with single flip-flop. 3-bit counter means this type of design includes 3 flip-flops. I am using T type of flip-flop. Mod 8 counters means 3-bit counter. So I am taking 3 T flip-flops. T terminals of all the flip-flops are attached to VCC. Clock is applied to the first T flip-flop. So this flip-flop is LSB, output is Q0. This flip-flop is MSB, output is Q2. Output of LSB flip-flop Q is applied as a clock to the next flip-flop. Same way, output of the second flip-flop applied as a clock to the third MSB flip-flop. This type of counter is called as asynchronous counter. As I mentioned that J is equal to K is equal to 1 means both inputs are connected at the same input. This type of flip-flop is called as toggle flip-flop, and we are getting the output in inversion state. So based on that, I am explaining this the state of the flip-flop. The Q0 initial state is 0. This is called as counter 0 state. At the 1 state we are getting 1, then count 2, count 3, count 4, count 5, count 6 and count 7. So at the first flip-flop we are getting inversion in the result. Same way at the Q1. But the clock to this flip-flop is the output of first flip-flop. So based on that we are getting the inversion in the result. And this way the counter can be designed. So this type of counter is called as asynchronous counter. Now see the example of mod 5 counter, which means that first state is 0, second state is 1, then count will be go to 2, 3 and 4. So how many states are there? 0, 1, 2, 3, 4. Total 5 states are there. So this is called as mod 5 counter, and then we have to reset the circuit, and again you have to start the count from 0. So this type of circuit is asynchronous type of counter, and this is mod 5 counter. How to design the logic of this counter? Count start from 0 to 7 in mod 8 counter. Total 8 states are there. So among these states, we want mod 5 counter the states from 0 to 4. So for 0 output will be 1, 1 output will be 1, for 2 output will be 1, for 3 output will be 1, for 4 output will be 1. After that we have to reset the circuit, so output will be 0. See the K-map of this circuit. This is K-map designed for the counter output QC, QA, QB. This is 0, 0, which means that QA bar, QB bar. This is 0, 1 means QA bar, QB. This is QA, QB. This is QA, QB bar. Likewise, this is QC bar, QC. I have written in terms of 0 and 1. And to keep 1 bit change in the numbers, so I am taking 1, 1 first and then 1, 0 to avoid metastable condition or fluctuations in the circuit between 1 and 0. So to avoid that metastable condition, I am taking 1, 1 first and then 1, 0. So I should get the 1 bit change in the form, digital form, which means 0, 0. This will be 0, 1. So there is 1 bit change. This is 0, 1. This is 1, 1. It's 1 bit change. And this is 1, 1. Next term is 1, 0. There is again 1 bit change in the digital number. So writing the output for 0, 0, 0, I am getting output 1. For 0, 0, 1, 1. For 0, 1, 1, 1. Likewise 0, 1, 0, 1. And then for 1, 0, 0, 1. And for the rest of the conditions, the circuit will be reset 0, 0, 0. Now writing the expression for this output, y is equal to, as per the K-map rules, first we should think about the octet, which means that group of 8 ones, then quad, which means that group of 4 ones. So I am getting group of 4 ones, and then think about the pair, that is groups of 2 ones. so I'm getting pair also. So simplifying the equations, so this is for this quad I am getting QC bar plus for this one pair QC bar and QC will get cancelled, so QA and QA bar dot QB bar. So y expression is QC bar plus QA bar dot QB bar. So what will be the reset logic? Mod 8 counter I am designing using 3 flip-flops, and for the rest of the conditions I am going to design the reset logic. So all the T terminals of the flip-flop I am going to connect to VCC. Then clock is applied to the first flip-flop, output of first as a clock to the next, output of the next clock to the third flip-flop. And as per the expressions, y is equal to QC bar plus QB bar dot QA bar. So taking the ending of QA and QB bar, so QA bar and this is QB bar, ending of this two inputs, applying to the one of the input of OR gate, and then this is QC bar. So taking the OR gate to add these two terms, and finally I am getting the expression of output y, and this expression is applied to the clear terminal of all the flip-flops, which means that after the state 4 output will be 0, the circuit will be reset, and again count will start from 0 and will go up to 4, and after 4 again it will go to the 0. Likewise the reset logic is designed. So this is mod 5 ripple counter, which is asynchronous type counter. Thank you.